Assalamu alaikum everyone, I hope you guys are doing well. So in the last video, I solved just one example question. Here it is. In this video, inshallah, I'm going to do some past paper questions to show you guys how easy this topic really is. Now, I know there's a lot of discussion around trigonometric graphs and equations and all that, but honestly, it's a piece of cake, as you guys will find out. Now, the tricky part, the part which is now tricky, is the fact that now you have a non-calculator part. So there are some questions which are, although previously from the calculator paper, but now that the format has changed, we're going to solve them without a calculator. And I've shared this PDF, and I encourage you guys to solve these questions as practice on your own as well. Okay, every time you see this symbol, just don't use a calculator in that question. Okay, so here's a question which says, on the diagram, sketch the graph of y equals to cos x. Now, pretty easy, given that you remember the values. Okay, so this part, the sketching part, can come in a non-calculator paper. So you got to make sure that you remember the values. Okay, if you don't remember the values, then just recall the shape of the curve, and that will help you recall the values as well. So you can see that at 0, when x is 0, cos is 1. At 90, it's 0. At 180, it's minus 1. At 270, it's 0. And at 360, it's equal to 1. So that means this is what the graph of cos x looks like. And that's it. You get two free marks, honestly, two easiest marks. Now, that's the answer to the first part. Then comes part B, which is a 3-mark question. And this also, I would say, is very easy. And this is the part where you must use your calculator. You can't solve this question without a calculator. So first of all, what you want to do is, every trigonometric equation, so before you solve an equation, unless it's a quadratic equation, you want it to be written in a certain form. Like, for example, if you're solving a linear equation, you would towards the end, the solution would look like you have x, which is equal to a certain constant. If you're solving an exponential equation, before you solve it, it's going to be, let's say, a base raised to the power, which could be an unknown, equals to a constant. So before you solve a trigonometric equation, you need to first bring it in a form where you have a trigonometric function on the left and a constant on the right. So that's exactly what I'm going to do in the next couple of steps. So 4 cos x is equals to 3 minus 2, which is equal to 1. And cos x is equals to 1 upon 4. Now, this is the standard form that every trigonometric equation should be in before you solve. Now, what's the step-by-step process? Let's revisit it. Step 1 is that you determine the possible quadrants. Now, how do you determine the possible quadrants? Notice that cos x has turned out to be positive. So that means if it's positive, it could potentially be in the first quadrant, or it could also be in the fourth quadrant. Okay, so these are the two quadrants in which your basic angle can possibly be. Now, the next step is that we find alpha. How do we find alpha? We find alpha by taking cos inverse of 1 upon 4. Now, remember, even if it was negative, I'll try and do a question where it's negative, we still take the inverse of positive. So as soon as you take the cos inverse of 1 upon 4, you get 75.5. So that means alpha is 75.5. Here also, it's 75.5. Next thing you want to do is you want to solve for the value of x. Now, how do you solve for the value of x? Here's how you solve for the value of x. You start from the positive horizontal axis. You go in an anti-clockwise direction till you reach the basic angle. So here, the value of x will be the same as alpha, therefore 75.5. And here, it's going to be 360 minus alpha. So 360 minus 75.5, and we're looking at 284.5. Now remember, all angles are to be given correct to 1 decimal place. Okay, so everything else, 3 significant figures, but angles in degrees are to be given correct to 1 decimal place. So that was it. That was one question. Now I would like to solve another question, and this time perhaps a non-calculator question. Yeah, so I'm going to solve this one. Now, once again, we have the graph of tan, so you should be able to recall the shape, and this is what the graph of tan looks like. This is one cycle, and then the cycle repeats, and here are your asymptotes, which although are already drawn, you don't have to draw them yourself. Okay, now, the vertical lines are already drawn. Not all of them are asymptotes. The asymptotes are basically at 90 and at 270. So at 0, we know the graph of tan is 0. At 45, it's 1. So somewhere over here is 1. And at 90, it's going to go to infinity. So that means this is what it looks like. And then at 135, it's equal to minus 1. Okay, so although it's a sketch, but try and be as accurate as possible. And at 180, it's going to be 0. So there you go. This is one cycle. And then from this point onwards, the same pattern continues. So it's going to be 1 again at 225. And then at 270, it goes to infinity. And then at 315, it's going to be minus 1. And right after 270, it will start from negative infinity. And there you go. Here is the graph of tan. Once again, 2 easy marks. Now, this is a non-calculator. This potentially could be a non-calculator question. Why? Because you're supposed to memorize these values. Now, notice that tan 30 is equal to what? Tan 30 is equals to 1 upon root 3. And here also we have tan x, which is equal to 1 upon root 3. Now, first thing, we see that it's positive. That means it could potentially be in the first or the third quadrant. Now, what's alpha equal to? So alpha would be equal to, if you want to find out alpha would be equal to tan inverse of 1 upon root 3. Now here's the thing, you can use your calculator, but like I said, this could potentially be a non-calculator question. Why? Because you're supposed to remember the value of tan 30, which is equal to 1 upon root 3. So that means if you're taking tan inverse of 1 upon root 3, it's going to be equal to 30. Like for example, sine 30 is half, which is why sine inverse of half is 30. So you're supposed to remember what sine 30 is equal to, and then you can use that information to figure out what sine inverse of half is going to be equal to. Okay, so here also alpha would be equal to 30 degrees. Now I would suggest that, this is something that you are likely to use. So I would suggest as soon as you get the paper in the exam, you draw this table. Okay, and I've already shared a video on how to draw this table. Make sure to check it out. There's a trick which you can follow, and that way you don't have to literally sit down and memorize all the values. So alpha is 30. That means this angle is 30, and this angle is also equal to 30 degrees. Now we find out x. So the first quadrant, in the first quadrant it's 30 degrees, and then in the third quadrant it's going to be 180 plus 30, which is equal to 210 degrees. Okay, and you can see that we didn't use a calculator in this at all. Now I'd like to solve a question where the value of the trigonometric function is negative. Okay, here it is. So let's solve this question. So it says sketch the graph of y is equals to sine x for 0 to 360. Okay, so recall the graph of sine. This is what the graph of sine is like. At 90 it's 1, at 270 it's minus 1, and at 0, 180 and 360 it's equal to 0. So a good idea would be to first mark the values on the horizontal axis. So 180 will be in between 0 and 360, 90 will be in between 0 and 180, and 270 will be in between 180 and 360. Now at 90 it's 1, at 270 it's minus 1, at 0 it's 0, at 180 it's going to be 0, at 360 it's going to be 0. Remember, you can just quickly draw this, and then this will help you figure out what the values are. Okay, now we're going to join all the points and make a nice and smooth curve. There you go, job done. Now solve the equation 3 sine x, solve the equation 3 sine x plus 1 equals to 0. Now first thing first, make the trigonometric function the subject. So sine x will be equal to minus 1 upon 3. Now notice that it's negative. Now because it's negative, that means our solution is going to be in the third or perhaps the fourth quadrant. Okay, so third or the fourth quadrant. Why? Because it's negative. Now next thing we do is we find alpha. Now remember, when you're finding out alpha, you will take sine inverse of positive 1 upon 3. Now what happens if we take sine inverse of negative 1 upon 3? I want you guys to do that with me. So you'll notice that you get a negative value. Now what do we know about alpha? The basic angle. Basic angle can only be positive. So if you take the inverse of the positive value, you will get the correct answer, and that is equal to 19.47, which, remember, angles are to be given correct to one decimal place, so we'll take it as 19.5. So here is alpha 19.5, and here is alpha 19.5 as well. Now the solution, we start from the positive horizontal axis, we keep on going till we reach the basic angle. So this would be 180 plus 19.5, that's equal to 199.5. And then for the fourth quadrant, the answer will be 360 minus 19.5, which is equal to 340.5. Okay, so these are very easy questions because they follow a standard rule. And which is why I would encourage you guys to solve these questions yourself. And I've shared this PDF. The answers are also there. Make sure to check your answer. And I hope this concept is clear to you. And that's it for this video. I'll see you guys in the next one, inshallah. So take care. Allah Hafiz.